Good morning, folks. In this video number 15, I will be exploring some elementary concepts related to the coefficient of restitution, and I will be doing the modeling in the motion design application of 3D Experience Release 2025x. Now, let me first explain to you what the problem is that I'm going to be solving. We have two blocks, A block, B block, and a track which is underneath it. And these are the dimensions that I will be using, but they're totally irrelevant. Suppose that block A has a mass of 2 kilogram and block B has a mass of 1 kilogram. And block B, for example, which is the lighter one, moves with a velocity of 2 meters per second. And block A, which is the 2 kilogram mass, is going to be moving with a velocity of 1 kilogram per second. Now, notice that what I want them to do is I want these things to collide with each other. So, and investigate the collision under different conditions, okay? This is a kind of problem that you do in your maybe first year physics class or second year dynamics class related to um, uh, um, conservation of momentum if they actually have a fully elastic contact. But anyway, so it's this type of problem. Now, what happens once the contact takes place on the very significant assumptions that you're going to make has to do with the coefficient of restitution. If the coefficient of restitution, which is essentially the ratio of the relative velocities after impact divided by relative velocities before impact, that's the coefficient of restitution. If E is 0, this is what we call the fully plastic contact. In other words, they stick together and they stop. Okay, because they, in the first case, in other words, the coefficient of restitution here tells you that the velocity of the two are going to be the same, and that's the condition that's required. Now, I'm going to model this thing with motion design. As you can see that these are two different blocks with different velocity. 1 kilogram block with velocity of 2 meters per second, 2 kilogram block with velocity of 1 meter per second, and they hit together and they stick together perfectly plastic. Now, this is the case where coefficient of restitution is 1, and if that happens, they hit each other and rebound at the same velocities, at the appropriate velocities. Okay, so not the same velocity, obviously. But anyways, we're going to be modeling these two problems, and this is done in motion design again. And theory says that if block A is a 2 kilogram block is moving with a velocity of 1, and 1 kilogram block is moving with a velocity of 2, once they hit each other and rebound under this condition, the velocities are going to be reversed. In other words, the 2 kilogram mass is going to go in the other direction at 1 meter per second, and the other way around for the other fellow. Now, if we don't specify contact in this problem, they go through each other. The other thing is that the shape of these two don't matter, but this statement is only true if I model this problem as two blocks traveling with a prismatic joint, okay, because notice that they are prismatic, but I will come back after I do this problem. Of course, I'm not going to do this additional shape change. I'm not going to do, but you can try it yourself. But if you don't model it with prismatic joint, what I said is not correct. The particular problem that I'm going to be doing here is done in a different playlist which deals in mechanical system experience and mechanical system design applications. and you can find it here. Okay, now a couple of things here. In this problem, I'm going to first do it with prismatic joints, both the two prismatic joints for the two blocks, and then I'm going to come back and do a remove this bottom track, and assume that these are traveling towards each other, etc., and then solve the problem. There are some issues that you have to be careful in this case. Okay. All right. Let's go ahead and do that. So we're gonna go to the experience. Let's start with uh, assembly design. There we are. Okay. I'm going to insert my 1 kilogram mass. So let me see. Yeah. So 1 kilogram mass is at the far end. So insert 3D shape. I'm going to call this thing 1 kilogram. I'll call it 1 kilogram. This is block A, right? Just double check on that. Sorry, block B. Just so that we can find things easier. Kilogram mass. We do a copy paste here. Okay. And I will make it or yellow, for example. Let's go make it. It's just a box. So on that plane, I will sketch. I'll sketch something like that and dimension it accordingly, 1 by 1 or 100 millimeter. These dimensions are not relevant, but okay, exit. And then we're going to pad it by 100 millimeter. Good. So this is my first block. And then I'm going to insert, new part. I'm going to change this thing to be base works. Yeah, this is going to be 2 kilogram. And it's going to be block A. And here too. And I'll make this thing pink. Okay, let's go make it. Double click. All right. Am I in part design? Yep, part design. So why don't I make this thing? Yeah. So I'll make it like that on the same plane. Sketch. I'll make my job easier. Project this thing so that I get identical size. Project that face. Yeah. Okay, and then pad it. And then pad it also by 100. Okay. Okay, now I'm going to manipulate these so that the two parts get separated from each other for visual purposes. So let me go to assembly design. I can manipulate and translate in, for example, direction X. This is direction X, and which one is it that I want to translate? I want to translate, this is the 2 kilogram mass that I want to move it away some distance. The actual distance doesn't matter, but yeah, something like that. And then fine. Very good. What we're going to do now is I'm going to create the track. So right click, insert 3D part. I'm going to call this thing track, properties, call it track. Keep in mind that I have not specified any mass yet. I just gave it a name, 1 kilogram and 2 kilogram, but I haven't actually done anything to specify the actual mass. Okay, and that's, we're going to leave it as gray, no problem. Let's go make a track. The actual length of it doesn't matter. On that vertical plane, see, on that, for example, on that vertical plane, I will sketch. So something like this. Exit. And I'm going to pad this thing by, let me see now, 1,000, maybe 600. So it looks like, maybe 1,000. Okay, that's fine. I'll make it shorter. 700, 800. Good, good. Okay, so all the way to the top. Now, because in the first part of this video, I want to create joints here, why don't I make my prismatic joints right now? Okay, let me make my prismatic joints right now. And to do that, first I'm going to fix the track. The track is fixed. And then I'm going to create two prismatic joints. So maybe prismatic. Okay, I'll use this template. It makes no difference. Axis to axis, edge to edge. So this axis and that axis, this plane and that plane. And I don't need the last three boxes, so I delete it. And then I say okay, and no. Then I'm going to make a prismatic joint between these. So prismatic between, once again, that template, this joint and that joint, this plane and that plane, and I don't need the last three. I'm going to delete them. Okay, so notice that two prismatic joints have been created here. Very good. Now, if you don't want to see any of these planes, so we know what to do. Control F, find all the planes everywhere, select them, and then once it's selected, then we're going to hide them. I don't need it. This step usually takes longer than I would have expected it, but anyway, we'll see. It's going to select them and then hide them right there. So I'm going to hide them there. It's nice and clean. All right, so we are done here. Notice that once again, we have not specified any actual masses here. So what we're going to do now is we're going to go to motion design, find it, motion design. As soon as you go there, it says that, listen, I'm going to create this mechanism for you, new mechanism, and say, okay, do it. So it is created. You can see that right there. A couple of things. Notice that, first of all, immediately certain markers are created. Now, these markers, what they are is associated with, there are three parts here. There are three parts, 1, 2, 3, and there's the ground, and you have four markers, okay? Now, you can see that here. Let me see, we have several bodies here. Ground is automatically created by 3DEXPERIENCE. This is my 1 kilogram mass, okay? There are markers because of the part, and there are markers because of the joints, basically. But the marker is actually right here. Okay? This is not a marker, this is a joint, okay? One marker here, one marker there, and one marker for the track. Very good. Now, uh, in fact, I don't particularly like to see these prismatic one. Can I hide it? Let's check that. Yeah. So let me hide these fellows so that they don't clutter. And one more. The joints I have hidden them. There are four markers. One for each part and one for the ground. Okay. Now, uh, if you double click on the 1 kilogram mass, it says the mass is 7.77 because when you don't specify properties, it takes the properties of steel and applies it to that block. And the density of steel is 7,770 kilogram per meter cube. So that's what it's good. Now, if I don't want this thing, and this I want to be 1 kilogram, you have to override the mass. You make this thing 1 kilogram. And I don't need these values, but if I did need them, I have to calculate it myself and put it in there. If you double click on the 2 kilogram, again, it says mass 7.77. I don't want that, override it. And this is the 2 kilogram one. I can take a 2, and then we say, okay. Now the track, it also puts some mass here. I mean, this is not going to go anywhere. Track is stationary. But if you want, you can turn it into rigid massless. It really doesn't matter. But because it's not going anywhere, I'll just leave it the way it is. Very good. Okay, now we have to create several things. The joints automatically are the joints are automatically created in the motion design here. It's not that it's actually coming from the engineering connection that I created earlier, and it's turned into joints here. Good. Now we want to create a contact between these two, so we go to mechanism, find the contact, 3D contact. This is fine, so I select this block, 1 kilogram, and then I select the second block, okay? And I don't need to actually create the contact between the track and these things because this is a prismatic joint. And basically, prismatic joint means that there's no contact between the track and these things. So we say, okay, now, the only thing is that for contact, this is where we specify the different kind of coefficient of restitution. So let me make, for example, fully plastic. So 0, fully plastic. We say, okay. Okay, very good. Then we have to specify initial conditions. So we go to initial conditions. We can do it by the marker or we can do it by the joint. Why don't we do it by the joint here? By the joint. Let's do the first one, the first prismatic joint. This is a 2 kilogram mass, which was the 2 kilogram mass. Yeah, this is the 1 kilogram mass, which is the yellow one. Okay, so we want velocity. The only thing is that we want this thing to be 2, but you may have to fool around with the signs to make sure that they go in the proper direction. So what I'm going to do is I'm going to make it a 2 and do 1 for the other fellow, another initial condition. This is for the for joint. For this joint, this was a 2 kilogram mass, and we are going to give it velocity, and then we're going to give it a -1. Now, if they go in the wrong direction, then we have to flip the signs. Okay, let's check it out first of all. There's the preview. You can see that preview animation. Just give it time. Yep, wrong direction. Okay, no problem. So exit that. Go back here to these initial conditions. Initial conditions. This one, I'm going to make that thing minus. This is a systematic way of deciding who is what, but it's not worth trying it right now. 1. Say okay. Now let's do the preview. They should go towards each other. Okay, very good. Excellent. Now, get out. What's the duration of the contact here? Not the contact, duration of the step, 5 seconds. Let me see now. This, for example, goes 2 meters per second. This is almost, so that's, I can make this thing too shorter time. Yeah, that's okay. All right, so now we're going to run it. So let's go to simulation, run it, wait until this thing finishes. I may have to do some adjustments. You'll see that later. First of all, let's select our result here and go to results. There's animation. Let's see if it's okay. Remember, they hit each other and they stick to each other because it's a fully plastic contact. Momentum has to be conserved, so they don't go anywhere. So this is the correct behavior. Let's do the plot. So 2D plot. So let's go ahead and do it for the 1 kilogram mass, velocity in the x direction. There we are. Okay. And then the 2 kilogram mass, velocity in the x direction, added. This is exactly what we expect. And that agrees with this case. Okay, let's do a fully elastic. So what we're going to do is I'm going to close this. Okay, keep this thing open. Now we go to contact. And for the coefficient of restitution, I make a 1 and run it again. Simulation, run it again, automatically will update those things. There we are. And note, this is the case where it's fully elastic. In other words, one thing, the block that was going at 1 meter per second is going to bounce back and goes in the other direction at 1 meter per second. Same thing with the one that was going at 2 meters per second. It's going to go in the reverse direction at 2 meters per second. Now, inadvertently, when I was doing the first few minutes, I might have said that the velocities are going to exchange, but that is not correct. It's just that the direction is going to, because initially momentum is 0. The final momentum must also be 0. Okay, so anyway, so if I said that the one that was going at 1 meter per second is going to go in the other direction, reverses direction at 2 meter per second, that's really not what I meant. So let's go ahead and make sure that it is agrees with these plots that I have here. Yeah, right here. 1 meter per second. Yeah, 1 meter per second goes at 1 meter per second. 2 meter per second goes at 2 meter per second. Excellent. So basically we have, oh, by the way, if you want to do the animation to see that we bounce back, so select this 2D plot and go to results, animate, oops, that's what I want, not this, that one, play animation. Okay, that's what happened, right? Rewind. Let me do it like this. In steps, so they come, they hit each other, and they bounce back. Now, if you say, how come they didn't hit each other? It actually did, but the thing is that when you created your, let me get out of this, when you created your dynamic step, double click on it, go to setting results output, instead of 20, make it 100, say okay, run it again. You see it looks a lot better for visual purposes. Okay, so let's check that. Close this, select this, results, animate, and you do it one step. It's going to be a lot nicer now. They get closer to each other, and effectively shows you that they hit there, okay? And they separate. Good. So what I want to do now is actually repeat this problem, but without any uh, track. So I can go and repeat the same problem, but I'm too lazy. So here's what I'm going to do. Let me go to mechanism. Let me uh, uh, actually let me go to simulation. Let me go to simulation tab and analysis case, a new one. Remember, the one that we already created says mechanism 573, okay? And we want to create a new one. We want to create a new one. Say, okay. There, you see that we now have another mechanism, 7.4. A couple of things you want to do. First of all, I want to deactivate gravity, because if the gravity is acting, these will just fall down, okay? It doesn't happen in the case of the prismatic joint, because that won't let it happen. So I'm going to deactivate this. Deactivate. Good, good. Now I go to bodies. I don't want the track to be there, so right click, delete. I go to the see now bodies are gone. Right, very good. Okay, we don't want any joints, so the joints did not come here. Okay, the joints did not transfer. Now see, there are no joints here, which is fine. Okay, so what I'm going to do is notice that these markers are somewhere at the corner. Okay, at the corner. That's fine, because I want to show you something. I don't want to see this track either, so I'm going to hide it. All right. So let's go ahead and create our joint. So no joint, create contact. So we go to mechanism, 3D contact, this part and that part. And if I want to see it more, so let me see now. So this one, I want let's look at the fully elastic one, for example. One, doesn't matter. One. So okay. Now these, I'm not going to touch what you did at default values. Okay, so we say okay. All right. Now we want initial conditions, just like before. So we go to initial conditions. Now we cannot do it with joints because there are no joints. So we say with markers. The markers are, for example, for the mass 1, here's the marker we selected. Okay, right there. Because I don't have any joint, I can't do it here with this icon. So now then I'm going to say translation, then the x direction velocity, and I can't remember what we did. If we go in the wrong direction, we're going to fix it. So I think this one, we made it -2. Okay, and do another one, another initial condition. This one is going to be for marker for the other piece, which was here, 2 kilogram. Okay, and then we're going to say okay, condition is translation, it's velocity in the x direction, and this one we're going to make it 1, and then we say okay. Now I'm going to show you something weird happening. So you click on the preview animation. Okay, first of all we have to fix the fix the velocities, the directions. So initial conditions, this one I'm going to make it 2. I can't remember what was it, 2, and the other one is 1, -1. The other one is -1. So okay, Preview. Good. Now, couple of things we're going to see. First of all, let's exit that. Okay, I'm going to make the duration shorter. This is the second one. Duration. I'll make it 2. Okay. Now we're going to preview. Okay. Let's move out, zoom out, zoom out. See what happens. Preview. Yeah. Okay. So, but if you look at it from close by, you're going to see that. So we say exit that. Actually, let me make that duration even shorter. Make it maybe 1. Let's try it. Okay, very good. But look at the way they separate from each other. So close that. Oops, get out of that. Let's go simulate it now because we want to look at it more closely. So simulation run. Okay, very good. Select the results there. Go to results, animate. You see that? That's not the way it's supposed to behave. And it is unfortunate, however, because this happens because the markers are at those corners. Why don't we go and create the markers right at the centroid of these blocks? So here's what I'm going to do. Let me go to what I'm going to do is go to these parts and create a point at the centroid and then put the markers right there. Okay, so we're good here. Let's go to the 1 kilogram mass, part design, essential, create a pointer, centroid, center of gravity of this pad there. A point has been created there. Now let's go to the other fellow, part design for the other part, the pink one, center of mass, center of gravity of the pad here. Another one is created there. Now we go to our scenario, which was, remember the 2 scenarios here, it really doesn't matter. We go here. Okay, good. Okay, so on the mechanism, we're going to create markers. A marker, select the body, this yellow body, and the point by geometry is that point that we created. Let me see if I can find my point. Well, let me select it from the tree. So this one right there, and do another one, another marker for this fellow, this geometry, and that's this point. So notice that I've created 2 markers at the centroid of these two blocks. And now we go to our initial conditions. Well, let's see now. Initial conditions. Let's say initial conditions. But I'm not going to use this marker. I'm going to clear the selection and select the markers that are created at the centroid, which is that guy, marker number 3. Okay, you say okay, and do exactly the same thing. Now we select our body 2, clear selection, the marker, I'm going to select it from marker at the centroid. Okay, so let's go ahead and simulate. And select this dynamic step result in the second step. So results and play. You see that? When let me rewind that. See, when the initial condition are specified at the centroid or center of gravity of those things, it looks a lot better. In fact, they bounce the way they're supposed to. As a matter of fact, let me go ahead and change the number of to be able to see that better. So I'm going to go to dynamic step. I'm going to change this thing to 100. Okay. And then run it, simulate. Okay. Select the dynamic step result, and let's show the animation. You can see in steps, this is where the velocity is no longer at the default marker, which were those corners, but they are at the centroid of that thing. And this is the case of fully elastic one. And you can plot the velocities, they're going to be okay. So the moral of the story is that I did not expect this thing to happen, but it sure looks it does. Okay, folks, good luck.